This is the velocity time graph of a body. We are asked to calculate the acceleration for the first 30 seconds. We are asked to determine the retardation, and also we are asked to determine the total time travel. Now let's start with the first question, which is the acceleration for the first 30 seconds. Please, I want you to pay attention. In our previous class, I let you know that when we are talking about acceleration in velocity time graph, acceleration is the gradient at that moment. Are you paying attention? Now we are asked to determine the acceleration for the first 30 seconds. You can see that this object now uniformly accelerates. Acceleration causes the velocity of an object to increase. You understand? So acceleration is given by change in velocity all over change in time. You understand? And it is v1 minus v2. You understand? All over v2 minus v1. Sorry, v2 minus v1 all over t2 minus t1. Or you can also use v minus u all over t2 minus t1. That is initial and final velocity minus the initial velocity all over the difference in the time. You understand? The final time minus the initial time. Are you paying attention? Now let's go back to the question. The acceleration for the first 30 seconds is this line. You understand? Line OA. Are you paying attention? So now let us calculate the gradient of line OA. You see, this is the initial time. You understand? This is the final time. 30 is the final time. 30 seconds. Now this is the initial velocity. 0 is the initial velocity. And 80, let us trace this. You trace the highest point. Please pay attention. It's simple. We are asked to determine the acceleration for the first 30 seconds. Now, I told you that acceleration causes an object to increase the velocity. You understand? So now, because of the acceleration, this object changes velocity from 0 to what? To this point. The velocity at this point is what? 80. You understand? Are you paying attention? So this one becomes the initial velocity, and this point becomes the final velocity. Are you paying attention? So the velocity at this point is what? 0. You understand? That is the u. U equals to 0. Now, the final velocity, which is the velocity that it attained because of the acceleration, is what? 80. Are you paying attention? So v equals to 80. Now let's check the time. The time here is what? 0. You understand? Because it's not moving right now. So the time is 0 here. So t1 equals to 0, and t2, which is what? T2 is 30. You understand? So t2 equals to 30. Now, having gotten all the parameters that we need in this formula, we can proceed to determine the acceleration. Hence, the acceleration here is equals to v minus u. V is 80. So I'm going to have 80 minus 0 all over t2, which is 30, minus 0. You understand? I'm going to have 80 minus 0 is 80. 80 divided by 30. 80 divided by 30 will give us let me point my calculator here. That is 2.67 meter per second squared. Okay, acceleration equals to 2.67 meter per second squared. You understand? Okay, so now, having determined the acceleration, let us proceed to the second question. We are asked to determine the retardation. Retardation is negative acceleration. It is the kind of acceleration that brings the motion of an object to rest. You understand? Okay, you can look from this diagram. Where is the retardation? Retardation causes the velocity of an object to reduce. You understand? So now you can see that this point, from this point to this point, the body accelerates. Now, having accelerates to this point, the body maintains a constant speed, constant velocity here. From this point to this point, it maintains a constant velocity from this point to this point. Now, having gotten to this point, it begins to decelerate. That deceleration is what we call retardation. You understand? Another name for retardation is deceleration. Are you paying attention? So now, after getting to this point, the body begins to decelerate until it comes to rest. Are you paying attention? Now, the retardation is this gradient. Are you paying attention? Line BE. That is the retardation. Are you paying attention? Because that is where the velocity changes from this point and begins to decrease. You understand? It is from point B that the velocity begins to decrease. So it is from this point that we are going to calculate the retardation. You understand? So when you are given a questions in maybe you are given a velocity time graph in exam, for example this, and you are asked to calculate the acceleration. All you have to do is that look for where the velocity attained its peak. You understand? For example, the velocity attained its peak here. This is the peak of the velocity. So it starts from here, then it attains its peak. After having gotten to its peak, it maintains a constant velocity. Are you paying attention? So you can see here is acceleration, here is a constant speed, then the other part is what? Deceleration. Do you understand? So in order to calculate the retardation or deceleration, we're going to make use of this side. Now, retardation is negative acceleration. Are you paying attention? So this point, please pay attention. This point to this point, that is the retardation. That is line A, line O, line BE rather. Line BE is the retardation. So in order to determine the retardation, we are still going to make use of change in velocity all over time. You understand? Now, the velocity at this point is what? 80. The velocity at this point is 80 meter per second, because if you trace it, we are going to get 80. Now, the time at this point is what? 60. 60, t equals to 60. Now, this velocity is u. You understand? Please pay attention. It's very simple. This velocity is u because u is the initial velocity. The reason is because that is the velocity at which the car or the object begins to retard. You understand? Pay attention. The velocity at this point is known as u. That is the initial velocity because that is the velocity at which the body begins to retard. It begins to decelerate at this velocity. Do you understand? Now, the time to that velocity is what we call t1. You understand? Please pay attention. The time at which the velocity begins to decline under deceleration or retardation is what we call t1. So here we could call t1. t1 equals to 60. Do you understand? Now, the final velocity will be 0 because when the object comes to rest, there is no velocity again. Are you paying attention? There is no velocity again when the object comes to rest. So the velocity here, which is v, equals to what? 0. And the time at this point is what? 100. You understand? So t2 equals to 100. Do you understand? So acceleration, now we know that we are dealing with retardation. Do you understand? We are dealing with retardation. That will be okay, let me just put R. Okay, retardation equals to final velocity, which is 0 minus 80, which is the initial velocity, all over final time. That is what? 100 minus 60, that will be what? Negative 80 all over 40. You understand? That is what? Negative 2 meter per second squared. But we are going to take the magnitude. You understand? So retardation equals to 2 meter per second squared. Do you understand? So we've determined the acceleration and the retardation. Now let us determine the total time taken for the journey. The total time taken is the summary of the time at which the object or the car or the body used to accelerate, maintain a constant speed, and decelerate. You understand? Now let's go back to the graph. The time which the body used to accelerate is what? First 30 seconds. So the time from this point to this point is what? 30. Now, having attained a velocity at 30 seconds, it maintained a constant speed for a particular time. That time is what? From this point to this point. You can see that the speed is constant for this time, this point to this point. The speed is constant for this time. You understand? So the time from this point to this point is what? 60 minus 30. You understand? That will be what? 30. Okay? So this is 30. From this point to this point is 30. From this point to this point is also 30. Now, having reached this velocity, it then decelerates. Having undergone a constant velocity, it decelerates from this point to this point. Now, we need to know the time from this point to this point. The time from this point to this point will be 100 minus 60. You understand? That is what? 40. Do you understand? So the total time taken for the journey, the time taken in seconds for the journey equals to 30 seconds plus 30 seconds plus 40 seconds. Okay? That is what? 100 seconds. You understand? That is the solution to the question. Okay? If you have any question regarding this, let me know in the comment section. Okay? See you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay? See you in the next class.